My name is Daniela García, and I'm going to talk about if is it possible to measure the speed of light from electromagnetic waves produced by a microwave oven. First of all, what is electromagnetic radiation? It is another way from energy to travel through space, like the light of the sun or the UV rays. These are all forms of electromagnetic radiation, which exhibit wave-like properties. But how important is this discovery, and how can we see the relation between light and electromagnetic waves? Well, actually, light is an example of an electromagnetic wave, and in this experiment we will see how well microwaves work, tracking the physical properties of the waves in order to estimate the speed of light. The Greeks were the first ones to write about the origin of light. Aristotle, in specific, considered that light traveled instantaneously, contrary to Empedocles. He argued that the movement of light must take time to travel. Moving forward to 1667, Galileo Galilei experimented with lanterns and distance. Unfortunately, his experiment did not work. Many other physicists and scientists tried to measure this incredible phenomenon, but it was until James Bradley came up to the realization, thanks to the study of the stars, that the value was 301,000 kilometers over second. From this point on, the scientists all rumored perfected the value and stipulated that it was actually 299,792.5 kilometers over second using a microwave interferometer. The variables that I have identified are the independent variable, that is the cooking time, the dependent variable, the distance between the hot spots in the cooked egg white, and the control variable, which are the oven, egg, plate, ruler, and calculator. For the conditions, we have the control condition, that is the spacing between the cooked portion of the egg whites, and the experimental condition, the average distance between the cooked portions. But what do we need to do? First, you need a microwave. Then, remove the rotating plate of your microwave. Pour the egg white into an static plate and experiment with the time until you get an egg that it is partially cooked in some places and nearly cooked in others. Take the plate out and take a ruler to measure the space between the cooked portions of the egg white. First, center to center, then edge to edge, both shortest and longest. Then get the average of the distance between our cooked portions. Get the estimated error of your measurements. Find the frequency of your microwave in the label that is in the back, and calculate the speed of microwaves using the wavelength and frequency. Finally, compare your results with the published value of the speed of light. The materials you will be needing are a microwave oven, a plate, oven mitts, 3 to 6 eggs, a ruler, and a calculator. Here are my results. I did this experiment 3 times with 3 different eggs. First, I get the average spacing from center to center. For the first egg, it was 8.6 centimeters. From the second one was 7 centimeters, and the third one was 10.6 centimeters. Then I measured the upper bounds of error and the lower bounds of error of each egg. From this point on, I got the average of each bound of error, so my measurements would be nearly similar. I inserted a graph where I explained the number of eggs and the average spacing of each egg. Then I obtained the measures of a spread. The first thing that I did was put all my measurements in the column of values. With this information, I obtained the mean, the range, and the interquartile range. From this point on, I obtained the difference with the mean, that is the second column, and the square difference, that is the third column. These values help me to obtain the variance and the standard deviation. Both of these measurements help me to know how dispersed or spread out the set is. For the fun part, I have to compare my results with the expected value of the light. The first thing that I did was use the formula of the speed of light to obtain the wavelength of my microwave. My microwave has a frequency of 1800 megahertz. From this point on, the experiment stipulated that the spacing of the hotspots is equal to 1/2 of the wavelength of the microwave. So, with this calculation, I obtained that the spacing of the hotspots has to be equal or close to 8.33 centimeters. On the right side of the slide, I have my experiment with each egg. With the egg number 2, my values were not close enough to 8.3. They were lower, and for my third egg, my measurement passed the 8.3 that I had to have gotten. Contrary to my egg number 1, the measurement was pretty close. I measured 8.6 and the expected value was 8.3 centimeters. So I modified the formula by multiplying it times 2 because we had take the half of the wavelength of the microwave. So this gave me the result of 3.096 times 10 power 8 meters over second, and the expected value of light is 2.997925 times 10 power 8 meters over second. For the conclusion, it is really possible to measure the speed of light with your microwave. Here are some photos of my experiment of how I cooked the egg and the hot spots that appear in the egg white. It is very interesting how mathematically you can do this experiment and how physically you can also do it. It is very impressive that from your home you can do this incredible experiment that maybe you would not obtain on the first try, but if you got lucky like me, you would. That's it, and thank you for your time.